Welcome back. And in the studio with me now, here is Philippe Collon, Associate Professor of Physics here at Notre Dame. If you listen to Science Friday on NPR, you may have heard Philippe discussing his work detecting counterfeit art. Philippe, I'm sure a lot of people are wondering right now, how exactly do you do that? Explain.
So it's actually interesting. It's the techniques that you use and the nuclear physics techniques that you can use to detect small amounts of produced particles, of reactions, you can actually use to study art. There's an enormous amount of trace material that you can find anywhere, in art material and anywhere else, that can give you information on how old it is, on where something comes from. So what we can do is we can read that signal. It does, however, need art historians, artists and things like that to then interpret it. But we can provide that sort of needle in the haystack technique.
Yeah, my sense is I've been to Europe a few times. You have a European background, grew up in Brussels.
Yes.
Art is so much a part of European society. Is that what drew you to this? How does a physicist get involved in detecting counterfeit art?
It's interesting. It's actually totally different from that. Is the technique I work in, which is called accelerator mass spectrometry, is actually used a lot in environmental science. Mm-hmm. And what I was really interested in is nuclear astrophysics. So what I really study is small or very unlikely reactions in stars. But the same techniques, again, can be used in art. And a colleague of mine, Michael Wiescher, developed this new course that is called Physics Methods in Art and Archaeology. And then I sort of joined into that. And the idea is really to sort of sell physics to those students that traditionally would hate physics. The traditional sort of response when you tell somebody that you're a physicist is, ooh, I didn't like that in school at all. And that's about the last conversation you've had with that person. And this is a sort of way of getting them interested. And that's how we got fascinated by it. It's because it's something that is very approachable, it's very relatable. People generally don't ask us about nuclear reactions, but they do ask about art.
What other things have you examined with a particle accelerator?
So what we do here mostly, so that's one thing I have to make very clear, is we actually don't do art authentication.
Okay.
Because that has legal ramifications that are so beyond anything we want to deal with. But what we really want to do is we want to train the students in those techniques, and we want to develop the techniques, push them on. And so what we've done is actually work together with the Snipe Museum of Art, with the Department of Anthropology, and they have done a lot of analysis of some of the materials that they have found, specifically anthropology, copper in local Indian settlements. And from the analysis of the copper, you can actually find out if it's copper of European origin or North American origin. So that can help them to sort of find out who local tribes were trading with, things like that. Analysis of Pueblo potteries, and specifically the pigments that they used, allow you actually to find out if these were actually painted in Colorado, and so you get a lot of information from that. And so we've done most of that. Most of the work that we've done really is in collaboration with sort of local departments here on campus.
You know, there are so many CSI shows on television now. I'm seeing the roots of another possible television show now with the physicist who's an art detective.
Oh, absolutely. And it needs it more and more because, surprisingly, what I didn't know before we got into this is that art fraud is about the third largest amount of what you would call fraudulent money after guns, and so guns, weapons, and drugs. Art is the third sort of largest purveyor of money to the criminal. So it's absolutely fantastic from that point of view. And so yes, it is. There are more. I mean, frauds get better and better, and so techniques have got to get better and better. And actually, if you look, there's the Louvre in Paris actually has its own accelerator. It's called Aglaé, and they do 24 hours a day analyses of art. Just using these types of techniques. Here we use them more as a sort of teaching tool. We use them to work with students and departments, but they use it day to day.
This is fascinating. We need to wrap up, but I have one final question for you. Do you have a favorite case that you have worked on or piece of art that you've worked on?
Not personally worked on, but one of the favorite cases, and obviously it's one that is always fascinating to talk about, is the Shroud of Turin, that was actually
You worked on it?
No, we didn't work on it. No. But three labs that I know very well, all three worked on this. There was one in Arizona, one in Zurich, and one in Oxford. And they used the exact same technique that I use. to actually date the Shroud of Turin. And one can get into very long conversations about the Shroud of Turin, but it's one of the sort of fascinating sort of cases that has been looked at with these types of techniques.
It's been fascinating to meet you, Professor, and you have just proven to one and all that physics can be really, really cool.
I hope so.
I think you have.
So.
Thank you very much.